All right. Cassandra, I'm going to start with you. You had a bit of a wish list, some grayed out items that you're not including in your standard kind of set of analysis. And I think LIBS was maybe on the list. Do you have any questions for Sam while he's here? Or are there any other things on your list that are the next one that's coming?
We have done some LIBS analysis at Agnico Eagle. We just haven't done it as prolifically as we have for hyperspectral and XRF, just because of the cost associated with it. But I think that LIBS has its place and can be really useful depending on your projects and depending on the problems you're looking to solve at those specific projects. Oftentimes we're looking for gold. So unless there's something specifically wrong in metallurgical or geotechnical that XRF can't provide for us or hyperspectral can't provide for us, then we would look into it, absolutely.
I was also wondering if there was anything that you had, because I saw your timeline since 2020. Is there any technology that you've dropped along the way? So you seem to keep adding, but is there anything that you've dropped? You do this annual review. Is there anything that might be getting dropped in exchange for something else?
Not yet. I don't think so. I'm looking at my colleague, but I don't think we've dropped anything. But it doesn't mean we're not going to. As I said, depending on the project, depending on the problems we have, we might have to swap out some technologies for others. And that's part of the reason why we do the Tech Watch every year. Yeah.
I like that name, Tech Watch.
Yes.
Okay, a question for all three of you. How do you integrate downhole information with the information that you're collecting at the surface? Or do you collect downhole as well as the core scanning information?
Integrating mapping in a greenfields project with subsequent drilling, trying to have as many of as similar data sets as you can, utilizing those same tools. They're just, in some respects, they're very different questions that you're trying to answer. Like if you're doing a greenfields mapping project, well, you're still trying to establish whether or not it is a drill target. So in some respects, you're answering very different questions versus answering questions about, what is the grade of this? What is its volume? Those sort of things. But there'll be similarities, obviously, like, airborne hyperspectral versus getting it in the core, all those sort of things. There's definitely overlaps in what can be collected.
I would completely agree. I think the biggest thing is just making sure that your data sets speak to each other. That's because when you're looking at data, the last thing you want is inconsistent data. And whether or not that data is great is kind of irrelevant if your data doesn't talk to each other. So I think the biggest thing is making sure that you have the proper correlation, calibration that you need for both of those data sets.
Okay. Anything to add, Simon?
As for us, I really believe that the big value of that is integration data from multiple sources and making something that it's much greater. So taking down old data and correlating with drill makes really a lot of sense. But as for now, as a core scanning vendor, we try to raise up the level of what hyperspectral data can provide to their customer, to our customer, by making it much more simple and affordable and accurate and easy to use. So that is our main challenge for the next coming years. So bringing this core scanning technology as a commodity. So I guess next phase, we might get more involved in how do we take multiple sources and deliver a bigger package. But as for now, we kind of push this back to our customers and we try to give the best data possible in the shortest time possible. So that is really our focus.
Okay, I'll stay with you, Simon. The trailer there, does it come at different scales? Like if you're on a small remote project, can you take something like that? Or do you have a more permanent, not on wheels version for an actual core shed?
Yeah, good question. So this one, there's just one model, mostly a different variation, but we can install it permanently. The wheels can be removed, jack and remove the wheels for a permanent installation. But this unit will goes in the field or inside the core shack, and it's adapted. And regarding the sensors, that's the same thing. Everything is modular. So in some cases you want additional sensors, or in some cases you don't need them. Just pull them out, and you can adapt the imaging capabilities.
And what about when Agnico and Rio Tinto go out to do greenfields exploration? What mine-tested tools do you take out in the field with you? Because that's obviously a smaller budget, I imagine.
Everything from, satellite, high resolution satellite imagery, PXRF, handheld LIBS, mag-sus meters, connectivity meters, anything that's of generally low cost and can be used across different projects, we'll deploy it every time. Doesn't really matter. In some cases, you don't necessarily know or understand the value proposition of doing those things, but to not have the data, you will never know. So deploying as many things as possible that are reasonably feasible to do, that don't absorb too much time of the field team's work, do it, everything, all at once.
Anything to add, Cassandra?
I would just add, if you have the access to it, remote sensing, hyperspectral data. Yeah.
Do a quick scan of the room if anyone. Go ahead.
Cassandra and Sam, you both work for large companies, and you both mentioned kind of offhand in your presentations that you struggle a bit with the volume of data and making it kind of useful across the board. Can you just speak to that a little bit, and what kind of workarounds you're using to make your data sets talk to each other with this huge volume that you now have?
Yeah, and it's something actually I think that was touched on a little bit. We need to establish which teams need what resolution of data. So for geometallurgical purposes, they need a lot higher resolution. They're dealing with, potential grain to grain associations. So they really need that high resolution data. Where if you're just doing XRF lithodomaining using the geochemistry, maybe a 10 centimeter interval is fine if you've got a lot of dikes, a lot of small dikes, or potentially even 1 meter to 3 meters. So it's kind of finding that sweet spot of resolution of data and delivering that data to the people who need it.
I think it probably doesn't matter for a major or a junior. Having large volumes of data in remote environments is a challenge for everybody. And, we've probably all struggled with some GIS platform or another that's communicating with a server in the field, and the challenges even for that. So, building a robust plan as best you can to be able to manage that data in remote environments. We're lucky to have satellite communications these days. So, putting data on in the cloud is possible now in remote environments quite readily. Just having a robust plan to manage those data sets. I think it's the scales are different. A junior might have a few projects or one project. Rio's got many, so there's a scale difference, but on the individual project basis, it's the same questions, it's the same challenges.
Julia, go ahead.
Hi, Julia. Core storage. Yes. So are you able to use this technology to inform long-term core storage? Is there any trigger point in the scans you're doing that would cause you to discard core? Is anyone else doing that? I know it's hard for us to hear, but it's a real estate problem.
Well, digital twin, let's call it that, to use a term. We don't all hold on to projects forever, and depending on the jurisdiction, you have to leave the core behind on your property, especially in Canada, that is a thing. So as a company, having a record of that information when you've abandoned a project, well, that information is still valuable. It could be useful in another project. So we don't hold on to all of our core. Even if you're just not even disposing of it, you walk away from projects, it's no longer yours. So having a data set that retains as much information as you possibly can is important.
Yeah, I agree. I think that for Agnico, in our production sites, oftentimes we sample the entire core, so that gets rid of it, so that's nice. But for exploration, we're legally obligated to keep it, which is good in its own sense, because we have, like Simon said, we have scanned a fair bit of historic core as well. So maybe we didn't have great logs or great data from a specific generation of team on site. So if we have access to that core still, we can now get a lot more information from it, and we don't have to drill a new hole and spend the money to do it. So yeah, I'm a geologist. I'm a hold on to core.
And Dave's going to come take a thin section for his library. Bridget, did you have a question?
So in the last couple of years, Anglo has pivoted quite a bit further down the chain. So looking at linking these types of data, mineralogical and chemical. And I love, Sam, how you said we mine minerals. We're not mining the elements per se. Can you comment at all on, and by that I mean linking this down to belt, pit face scanning, underground, and linking these mineralogical variables further to the chain in terms of the reconciliation process. Do you have any programs in that? Is that something on your radar? Is that something you're looking at as further kind of embedding into your chain?
I can't comment too far on that, but in the early stages on exploration projects, we're very much front of mind now, creating a bit of a digital legacy on that project, where the data we collect now, in the past, okay, geotech doesn't matter because they're just going to re-drill all these holes. But if you can capture that data and it doesn't cause too much of a hindrance on the active greenfields drilling project, then you don't need to drill it again. So a legacy for the data where it can sort of pass through the value chain and still provide value down the road if said project goes into production. I think that's really important to consider even at the earliest stages. You may never realize that value. Most projects don't go forward, but we've all been on projects where you have a data set and you say, I wish they did this.
Go ahead.
Just a quick one. You mentioned resolution earlier there and making the resolution fit for purpose. Given that you don't always know the end purpose or all the purposes that may occur, do you capture at a high or reasonably high resolution to start and then smash it down depending on the purpose for the end use?
Yes.
Yeah, okay.
Yeah. Higher, just not super high. Like there's a balance there, but I think sort of our standard scan for the LUMO system, it's on the order. I think we can do like 16 meters a day, and then if you needed more, you would run 24-hour shifts, that sort of thing.
Go ahead, sir.
Nick Williams from Cobalt. With the spectral scanning methods in particular, is there a risk of becoming overconfident in what you think you know from the reflective minerals that you're seeing and getting great signal from and great responses from, and perhaps ignoring the things that aren't giving a great spectral response? Or is it an opportunity for you to actually put more human eyes on the dark rocks?
There's no one else on this side. So.
You're it.
That's a really great question. I think that comes to how do you process this data. So if you are overfitting with, you're using your machine learning to identify those spectrally active minerals and you're retraining with the same data set, I think that at some point, yeah, you might swim into your own, data set of training. But I think geologists would need to step maybe one level above at some point and accept that, okay, this is the mineralogy. We're not looking at spectral signatures and stuff. We have to trust that it is what it is. And if the system, the machine has learned a lot and is able to say that this is a carbonate, this is a biotite, Mg number X, I'm not going to look and refine the spectrum, because at some point now everybody is kind of learning and trying to make it reliable, but it will get there. It will be as reliable as any commercial lab. So I think we will just step one step further and begin working on data, assuming that the bases are strong. I not know if that's answering your question.
Go ahead.
Is it one of the benefits of like your machine learning models is you can assign a probability score to most machine learning models when you're not getting into like necessarily neural networks? So I've just dabbled a bit with some machine learning models, and the value I find is you can either have predictably wrong or also quantifying your uncertainty, provided that falls into your training data distribution. So I think kind of speaking to your point, it's like, okay, maybe we have areas that you've got like a high confidence prediction, but then you also can see what is the secondary kind of prediction, and then kind of see, does that make geological sense, or kind of start to assign some kind of probabilities to your predictions. And then maybe if you're at like a 60% probability, that's when you get, call in the senior geo, call in some eyes.
But the problem comes if you can't train on the dark rocks because they don't have a response to train on, then they're not going to be part of your prediction model.
Well, that's a very good question. I think your questions come from the fact that you've tried analytics software relying on machine learning for mineral identification, which is mostly the case by most of the people who are doing this today. But we have a different approach regarding that. So we use machine learning, we use those AI technologies, but at different level, not to extract mineralogy, but to understand what does mineralogy means in this geological context and give advanced insight, additional insights. But for the mineralogy purpose itself, because of the work of my co-founder, Philip, we has done extensive work in hyperspectral data processing for geology. We have a different approach. So we rely on spectroscopy absorption. So we've developed this huge database of spectral minerals built specifically with our own system. And we use this to extract the unique fingerprints of every minerals. So when we look at the shapes of the spectrum of the minerals, we know exactly what minerals it is, as opposed to statistical approach where people will put all those terabytes into a black box and ask someone to train that machine, and then over time, predictability will increase and statistically become more relevant over time. So this comes to what you mentioned as, is there any criterion to quantify how accurate is our prediction? It's because it's based on the amount of training you've put into the model. But we don't use this kind of model for mineralogy. So if you see this dip, this spectral signature, this really corresponds to OH bonds or specific bonds into the minerals, and it's rock solid. It's really correlated to the chemical and physical properties of the rock. So there's no this black box thing that do some, I don't say magic, but some interpretation that is statistically relevant. It's a direct interpretation. And one parallel benefit of that is traceability. So if you get this kind of output from the algorithm saying that is carbonate, what type and what grade, etc., you can trace back to the spectrum and confirm why would this algorithms gave you this answer. But in case of using machine learning for this, that's a black box. You've got the results. Some algorithms crashed and lead to this direction, but this is where you can have this uncertainty of why am I getting this result, how accurate it is, and there is no way to trace it back to the original data.
Was there one more comment? This will be the final one, and then we'll go to lunch.
Hi, Dimitri, Search Science Analytics. So I see three people there, but four techniques on collecting information from cores. Are you trying to combine all this with multimodal neural networks? So I see techniques from each of you trying to fit to a label, but are you trying to combine all the data for the same course, mainly to the operators?
We've tried all of these technologies, not together, but we've tried all of them. And I would say, just your previous answer, you choose the technology that is appropriate for the commodity and the deposit and the mineral system that you're exploring in. So I'm not an exclusive advocate for LIBS by far. It just depends on what you're exploring for. I think if you tacked everything all into one device, it would slow things down quite significantly, and that's a bottleneck on the projects that you want to avoid.
As I said, we have tried LIBS before on core that we have scanned with our traditional XRF hyperspectral, and the problem that we were running into is different resolution of data, unfortunately, and trying to exactly map the data to each other is very difficult when it's coming from two different vendors.
Thank you.
Okay.
We'll try to be short on this one, but that's a good question. I think it's project dependent. What are you looking for? Stage dependent as well. If you are really greenfield exploring a new project, you have very minimum idea of what you're looking for. Technologies that are really like micron focus, really detailed and providing a lot of extensive data might be the solution. If you're moving forward, you're getting to know the deposit, you're going to have more drilling, and you're looking at workflow and just a really extensive, broad scanning, you might lean to other technologies. But I agree that the combination is something that will probably solve the problem, because none of these unique technologies can do it all. But it has to be modulated based on the project type, the project level.
Simon, I was trying actually to solve the question that was raised on the right. I believe, because I really believe what we are doing. Building commodities that are data that are collected all the time is important for the industry. If we are able to have 2, 3, 4 different sources of this type of data, and then make multimodal systems that actually collect and each cover the whatever is missing from that data set, I think it's the way to go forward. So I really appreciate what you are doing. I mean, this type of data, commodity that we know always we see the same data on our fields, it's really important.
Okay, I'm going to cut the conversation up there. We can continue it over lunch. If everyone can join me in thanking Cassandra, Sam, and Simon, our second panel.